Thank you. Thank you. Hi, y'all. I hope you guys used the break to catch a little bit air or to get a coffee, because we're approaching the end of the day, and I know you guys already heard a lot of great talks, and you're kind of fed up with information. So I know, especially since this is another testing talk, you guys probably think, well, should I listen to this guy or rather fall asleep to be ready for the party? And I'm pretty aware that my performance here on the stage is impacting that decisions, and my goal is to kind of like keep you engaged with the content that I want to deliver today without you falling asleep. And in fact, my topic is kind of related to that. It talks about performance and how the user perceives the performance of the browser. And I especially want to answer the question how we can test this with today's JavaScript. Before I get into the topic, let me introduce myself. I'm Christian. I work as a software engineer for Source Labs. I do a lot of open source things, and the team I'm working in at Source, it's called the DevTools team, and we're trying to build testing capabilities on top of WebDriver. And one of those testing capabilities is, inspecting the network while you test your browser, or another is performance. And the reason why I really got interested into performance was that performance becomes more and more important as a non-functional aspect of your application. And if you just look at some numbers here, some of them we already heard today. 53% of mobile site visits get abandoned if the page takes longer than 3 seconds to load. The average page size is 3 megabytes, and the average load of a web page is 3.21 seconds. We put more and more stuff on the browser, on the shoulders of the browser, and we expect the browser to still load the application fast. Also, Google has their take on that. They say, how fast your website loads is critical, but often a completely ignored element in any online business, and that includes search marketing and search engine optimization. That means if Google finds out that your application loads slow on mobile, they will decrease your page rank. So it will start with your customers, leaving your application because it takes too long to load, and it ends if your application or your web app is not even present on the Google search. Performance matters. You guys probably have already heard about this term. It's a global movement from web developers from all over the world to push performance, to teach about performance, to create conferences and talks about that, and to build tools. And we have great tools like Lighthouse that allow us to inspect the performance of our web app, but there hasn't been much evolved in the testing space. And I want to answer that question today. Let's see. There was this American businessman, Harold S. Genin. He lived in the 70s. He had probably no idea about web performance, nor about the internet. However, he said, performance stands out like a ton of diamonds, but non-performance can always be explained away. And that fits it really well. We have all these great toolings. I mentioned Lighthouse already. We have all those great toolings that allow us to inspect the performance of our web application, but we don't really take performance that seriously that we're going to test it. I want to see, by show of hands, who of you has a performance test in their CI/CD pipeline to test performance on a regular basis? I see 2 hands, 3. See, we don't. That is some. I'm happy with that, but it's not enough. We should test performance every time. So before we get into performance testing itself, let's look into what performance even mean. What does it mean when I ask myself how fast does my web app load? One of the first metrics that we can look into is the time to first byte, and this metric is really impactful because it shows the duration that it takes when you press enter in your browser and your server responds with the HTML page. And the reason why this metric is impactful is if your server doesn't respond, you sitting there doing nothing, your browser is sitting there doing nothing, so nothing happens until the server responds and the browser can consume something. So if that metric is bad, every other metrics that we will see in a second will also be bad. Once the browser has received the first HTML code, it starts parsing the HTML, right? It starts parsing HTML, it starts parsing the CSS. And we can then look into some rendering metrics. one of the first metrics that appear is the first paint, which happened as soon as the browser starts parsing some CSS and is, put out his pencil and draw something on the web page. Once the browser then continues further and parses some HTML, it then, tries to draw some HTML elements on the page, and we call that the first meaningful paint, first contentful paint. And then after a while, the browser has finally finished parsing the whole HTML page. We see the more meaningful things of the web app, and we call this the first meaningful paint. Last but not least, the time when I finally am able to interact with the page, scroll around, do something with the elements there, we call this time to interactive. Another interesting metric is speed index. Speed index was created by WebPageTest.org, and it tries to find out how well the page renders. So we have two examples here. On the top, there's an optimized page that uses progressive rendering, and on the bottom is an unoptimized page. And you see, with progressive rendering, the browser draws element on the page as soon as the browser has parsed it. So we immediately have something to consume, creates a much better experience. And the speed index tries to find out how much is already being drawn on the page. And you can see on the right, on the bottom part, like there's nothing being drawn until everything pops up. And you see in the graphs, the red area pretty much represents the amount of things that have been drawn on the page. And if the white area on top of that is big, then the speed index big and creates this overall score. So of those metrics we just have seen, we call them milestone-based metrics. There are other types of metrics that we can also look into. Those are named score-based. You might have heard about the Lighthouse performance score. And others are resource-based. It's when you say, I don't want to load more than 250 kilobytes of JavaScript. And you might ask yourself, well, are all these metrics really important to me? Should I really care about all of them? And the answer is yes, because how fast an app page, if you say my app loads in 5 seconds, and that is fast. Fast is such a vague term. What does fast even mean? And some smart people at Google, they've tried to answer that question by raising a couple of other questions. First is, they asked, is something happening? So did the server respond? Did the navigation even start? And we can answer that question by looking into the time of first byte metric. Then they ask, is it useful what is being shown there? So is enough rendered so I can engage with it? And that can be answered with the time of first paint, or time to first contentful paint. Then, is it usable what I see there? Can I interact with it? You can answer that question with time to interactive. And last but not least, is it delightful what I see there? So can I use the application? Is it without jank and all the stuff? And you can answer that by looking into the long task of the browser, the main thread blocking task. And you can think about that like a restaurant visit. If you go with your partner to a restaurant here in Amsterdam, and imagine you would sit down and you have to wait an hour until the waiter comes. And then the waiter comes, he brings you the menu, you order something, and then he immediately comes back with the food, including the check, and asks you to leave the restaurant. That would be like a terrible experience. You would never go to this restaurant again. On the other side, though, imagine you go into a restaurant and you sit down and the waiter brings you immediately a cup of water, asks you what you want to drink. You order white wine, then he brings you white wine, and then you order your entries, your main dish, and every time that you have ordered, you're already consuming something else, and that's much more delightful. So Steve saw this put well. He said, fast forward to today, and we see that window on load doesn't reflect the user perception as it did once. And that's true. If you say my app loads in 5 seconds, it's technically not wrong, but it misrepresents the reality. You should really care about the user perception and how the user perceives the performance. To answer that question, let's look into browser tracing, and let's look into how browser perceives the page load and the page performance. So we're all developers, right? We all have done something like this before. We open the DevTools, and we go in the Performance tab, and we scroll around and see what's happening during the time we have traced the browser. Have you ever asked what's behind it? What actually happens here? So I was asking myself that question. I looked into what's actually in those trace logs. And those trace logs are JSON files that contain a bunch of trace events. A trace event can have different types. There are like duration events, complete events, instance events, a whole variety of trace events that you can define, and they're actually defined in a specific trace event format. And you see on the right side an example of that, a really simple trace event that I created. It has a name. It is connected to a category. It has a specific type, a timestamp, a process ID, a thread ID to where it was executed, and it comes with some arguments. And popular areas where you might have seen those trace events in action are in the performance tab, right? You probably have seen that graph that describes the JS heap size, the amounts of documents and nodes that have been loaded, and the listeners that are registered. And that graph is created by the update counter trace event. It is in the DevTools timeline category, and in their arguments, it has all the information that it needs to create this nice little graph. Another popular example are the screenshots that you see. They are called screenshots. In their arguments, it's a base64 encoded image, and it's in the category disabled by default. It's DevTools screenshot. The reason why it is prefixed as disabled by default is because those kind of categories technically impact the browser performance. So you want to be careful if you want to trace those kind of information, and only do it if you really need to. And yeah, with those trace logs, there can be like multiple megabytes of size, and you would never use your editor to scroll through all these events to reason about it. Luckily, we have great tools like Lighthouse that do tracing for us and make actually sense of the data that's being captured in there. Lighthouse is a great tool. It gives you all the performance metrics, including diagnostics and information about how you can improve the performance of your application. WebPageTest.org is also a great resource if you want to get insights about how your page actually loads. But I have two problems with those tools. For one, they are difficult to set up when it comes to testing. When I speak to QA developers, they are not really front-end or application developers. They have a hard time to set this up and get reliable results. And a more crucial problem for me is that those tools only take an URL, and they only trace that page load of that simple URL. But what happens if I want to capture the performance and measure the performance of things that are behind a login, things that only appear when I have set up my application to a certain state? I need to have some automation steps before I can actually load the page. Those tools don't give me that ability. So I was thinking, how can we get access to performance much easier, and how we can create some automation steps before, so I can bring my application to a certain state. I thought, well, I do WebDriver for a living. Why not connect WebDriver with it? And before I show you how you test performance, let me use some seconds to talk about WebDriver a bit, because it gets a lot of people have confusion about what WebDriver is, and they confuse it with Selenium, and then it means, oh, Selenium, isn't that something where you have to have Java installed and it's like super old? It's not. I'm a Node developer by heart. I have not Java installed there, so WebDriver is pretty much our automation platform or automation protocol today. It's a W3C standard, like CSS or all the other browser APIs. So every browser vendor that provides a browser is encouraged to provide us a driver that allows us to automate a browser today. And if you look into the spec, you will see a bunch of REST endpoints being defined there. There are REST endpoints that allow you to get a browser session, like it starts up a browser. There are REST endpoints that allow you to open a specific URL, to engage with elements, to click on elements, to go back, go forward, all that stuff. The protocol is designed to allow you automation from the user's perspective. Everything you can do as a normal user, you should do with the protocol cross-browser. And the reason that it's HTTP request is the idea you should use any tool that you want. Any programming languages can send HTTP requests these days. You should do whatever you feel comfortable with. The normal setup of end-to-end tests today looks pretty much like this. You have a test code written in Selenium or other tools like WebDriver. And those tools send HTTP requests to something called a browser driver. That browser driver takes those HTTP requests according to the spec and then do their part to automate the browser that you don't even need to care about. On mobile, it's even more difficult because every mobile OS comes with a different automation framework. But there's Appium who wraps those kind of frameworks into drivers, so you can just speak simple WebDriver to it. And as I mentioned before, and as Maxi mentioned in the introduction, I'm maintaining the WebDriver project, which is a JavaScript framework to do end-to-end tests today. It takes care on all the stuff that you need to care about in terms of parallelization. It has a bunch of plugins. And one of the plugins that I wrote is a so-called WDIO DevTools plugin. And the responsibility of that plugin or that service is to create a second connection to the browser. I mentioned before that WebDriver is designed to allow you automation from the user perspective. However, capturing performance is not something that a user would do, right? It's something that we would do. So that service creates a second channel to the browser that uses the native APIs, the Chrome DevTools APIs, and provides you ability with commands to get performance metrics out of it. And I've prepared a little demo for that. So I have a small application here. It's Tony's favorite food. It shows Tony's favorite food. And then I have set up a simple project. It's big enough, yeah. It's a simple project where I want to test the performance of that application. So WebDriver defines a configuration file where you define your capabilities and which browser you want to run your test in, where your specs are defined, where your specs are, the max instances, and all that stuff. But most importantly is that I've defined a DevTools service here and a Chrome driver service. So whenever I start WebDriver, it starts Chrome driver for me, and I can automate the browser. So what I want to do now is I want to test the performance of my application. And as I said, if you put in the DevTools service, you get the command that is called enable performance audits. And I can define the throttling capabilities and if I want to use cache or not. And then I just open the browser, and I then just query the metrics that I got from it. The performance score, as well as some main metrics, which is the first meaningful paint, time to interactive, and the speed index. After the URL command, I could do anything that I want, like click elements, enter some new items, create users, whatever. In this case, this is really simple. Just open the URL and get me the metrics. A second test tries to answer the question whether, tries to do assertions for resource-based metrics. So I open the URL again, this time without throttling, because I don't do performance tests in there, just resource tests. And I make sure that the images and my JavaScript is bundled. So let me run this, npx. So what it does now, it starts two browsers. And it does, for every test file, it creates a new browser. So I get every time a fresh browser with a fresh profile. And it tests the performance. Right on. And still running. It waits until the CPU is idle, and sometimes that can take a while, and apparently too long. See, this is the thing with live demos. If it works, we all are amazed, and if it not work, we just don't care about it, right? So sometimes it's the same in Lighthouse. So sometimes your capturing performance fails, but we see that the page rate, all my tests passed in there. So what I want to do now is, I just ignore the fact that this test actually didn't work. But what I want to do now is I want to put some performance problems into my application. So what I do is I say my Webpack mode is development. Development, I want to ignore compression. And my favorite thing to do is mine Bitcoin, because the crypto space is hot right now. So I wait until the application is deployed and run the test again. All right. So I'm going to run this test again, and this time it should hopefully fail. Video WPXW. So you see now that the application already loads slower because the mine Bitcoin function will block the main thread and block everything from happening until the 1.5 seconds are over. And we run the same test again. And hopefully now, I can capture all the performance metrics so that we can see the test actually being working. There we go. And close up. Yay. OK, so what I have here now that I checked all the metrics, first mean full paint, first interactive, speed index. And you see they're 3 times as big as before. My Lighthouse performance score, the DevTools service uses not only Puppeteer to automate the browser behind the scenes, but it also uses Lighthouse to capture all the metrics based on the tracing data that I got. And I got a Lighthouse performance score of 33%, which is pretty slow. So this is amazing, right? We can use open source tools to automate our browser and get performance benchmarks out of it using great technologies like Lighthouse. All right. But this is not enough. There's still this one problem, which is I need to have the browser somewhere running. I need to have a stable environment. I need to run my performance tests on somehow a similar environment. Otherwise, I would get different performance metrics every time. Which is why we, at Source, we thought, well, we already have the biggest testing cloud in the world. Why not run performance tests on there? If you don't know what Source is, you've seen that slide before. If you run an internal grid like this, you would have to update your browser, all the browser drivers, and it can be really tedious, especially on mobile and real devices. So the proposition value of Source Labs is simple. You have just one endpoint that you call the request to, and we host all the browsers and all the mobile devices, being it simulator, emulator, or real devices, for you. And Source is interested into that because we want to shift testing to the left. This is kind of like a DevOps term. That means that we want you to test your application as soon as possible on every commit, on every pull request. We want to have you run end-to-end tests every time because we want that you push and publish applications with knowing that there's nothing wrong with it. And if we look at the current tooling landscape, we have like Lighthouse and DevTools, which are excellent tools to test the performance in the lab, to improve the performance of your application. And we have tools like New Relic or WebPageTest that allows us to get real user metrics from production. But there was this tool missing in the middle that allows me to just run it in CI/CD. And we created a tool that is called Speedo. I actually wanted to give this talk just wearing a Speedo, but the conference organizers didn't like that idea, so I put on some pants, but I'm still wearing Speedos under that. However, Speedo is an open source tool that allows you to run performance tests without knowing all the stuff about WebDriver, without knowing how the browser is created. You just run it and it works. The idea behind this is that you do npm install Speedo, and what it happens is it checks your account, checks if you've already run some performance tests. If not, it creates a baseline. I will talk about that in a second. And once it has a baseline, it runs a performance test. And then waits until the browser has shut down, downloads all the performance data, and asserts the performance of the page based on the baseline. So what does baseline mean? If you run a performance test on our platform, we know the performance fingerprint of your application. Every page load is different. Every page load has a different amount of CSS and JavaScript that is being loaded, that has to be parsed. And we know that. And we know the data, how it correlates, and how it is over time. So we create a baseline that has an upper and lower bound. And if we run a performance test and we see that this matrix is within the baseline, we say, OK, good to go, nothing has changed. But if we see that, hey, this metric is above the usual baseline, then we let your test fail. And I want to show that. So I hope I'm still logged in. So on the right side, you can see the source apps dashboard. And I was free to already run some tests to create the baseline for us. So if you go there, you have a performance tab. You can open the full report. And you can see the baseline, it's small, but it says the baseline is between 3.4 and 3.7 seconds. That means that we actually know how your page load actually looks like. And you remember that I added some errors in my demo application here. Those errors still persist. And I want to catch them now with Speedo. So what I do is I get their command for it. Oh, Speedo. No, which? So all you need to do is call Speedo run and give it a test name. And with -b, I attach it to a random build. So what happens now is that in our cloud, we spin up a browser. And that browser is running with the page with good 3G, with some CPU throttling. And actually, you can modify that call and run the performance in our EU data center or US. So you can also track how good your assets are served by your CDN. And if everything works, then OK, performance test is done, waits till the job is finished, it downloads. And we see there, we just tested the performance score because it's a good overall metric that we can look at, but we could also have tested all the other scores. So what we do now, we go into the test. We look into the, OK, let's do this again. We look into the performance logs. And you can already see the bump there. And it also shows you, how your baseline has evolved. The baseline was really small. And now you see, with just some performance bugs in your code, you have this thing spiking up and also the performance score going down. So this is excellent. Go back. So as I said, it's not only important to get the performance metrics for every page load, but also to get behind some sort of login or create a certain state in your application before you run the performance test. And if you run tests on source, you can just do whatever you do with your normal functional test, and then at the end use the analyze command to test the performance of a specific test from a specific URL. In this case, the Instagram.com once I'm logged in. Like I said, it's ready for CI/CD. That means you can plug it in your continuous integration pipeline, being it Jenkins or GitLab, using our Docker container. And you can even go more crazy and implement it as your own performance framework. That means that if you use WebDriver, you have an assert performance command in your utility belt. You again say the test name that you want to test the performance for, and give the metrics that you care about. And what we do is we have a WebDriver extension. That means that we have additional comments on top of the WebDriver spec. And we allow you to hit that endpoint to get all the information, whether or not the performance has passed, and which metrics have diverged. Before I end this talk, I want to give you some performance best practices that I discovered so far. Really, really important is that you should test your functional performance apart from performance testing. It's really critical because performance testing is, it tests the performance of your application, the performance of your application. It's like if you see the testing pyramid, you still do a lot of unit tests, you still have some integration tests, you do some end-to-end tests for your most important user stories. And performance testing is like the sprinkle on top of this pyramid. You should not worry about different browser versions and different browser OS systems. The browsers these days do a lot of benchmark testing to make sure that the engine is good. so you don't need to care about that. You should keep it simple. That means you should not test the performance of all pages that your application provides. You should provide and maintain a common job name for a performance test, because we create the baseline based on the name of the job that you run. And you need to know what you want to test. The Lighthouse performance score is a great general metric that gives you a lot of insights about the performance of your app. But if you're like an e-commerce shop that really cares about that users can engage with the search bar as quick as possible, you might also want to look into the first contentful paint. With that being said, I hope you guys are all interested in doing performance, because performance testing is not really taken care seriously these days. And I think if we all do a little bit more performance testing, we create all a better experience for us all on the web. Thank you.